Welcome back, and this is probably the last video of week 2, and I might even do the box notation of electronic configuration in week 3, or I can do it this week, but we'll see. But we got one more concept to get through, which is electronegativity. Okay, obviously if you literally read, this translates into electron, and this obviously translates into negative. So obviously we're dealing with electronegativity is the tendency, the definition, okay, the tendency of an element, okay, to acquire electrons into its valence orbital. Okay, now a lot of the time when people define it, they don't say the word valence orbital whenever they teach us. That's very important, because you don't just throw the electrons wherever you like. All right, so it's valence orbital, and electronegativity also has the same trend as ionization energy. Electronegativity typically increases from left to right on the periodic table, and it decreases from top to bottom on the periodic table. All right, so this is with respect to the periodic table. Very good. All right, let's do some examples, because obviously that's what you're looking for, is can you do us some examples? All right, let's do some examples. So let's do hydrogen, lithium, sodium, potassium, oxygen, and nitrogen. Okay, you have to sort these elements in the order of increasing electronegativity. As always, you're going to go from the smallest to the largest. Okay. All right, so I said electronegativity increases left to right and decreases top to bottom. Of course, there are exceptions, and we're not going to get into the exceptions. Okay, so let's get the periodic table. All right, so we notice right away lithium is below hydrogen. Okay, so lithium has a slightly smaller ionization energy compared to hydrogen, right? Now, where are the rest of them located? Well, sodium is directly below lithium, and potassium is directly below sodium. So potassium is right here, followed by sodium, followed by lithium, and then hydrogen, right? Now, what are this left? It's only oxygen and nitrogen. Well, where is oxygen? Well, it's on the same line as lithium, and nitrogen is in front of it. And as I said, electronegativity increases as you go from left to right. That means oxygen's got, okay, so it's somewhere here. So nitrogen's here, oxygen's here, because they're all below hydrogen, right? So let's put them in the order. So it will be potassium less than sodium, less than lithium, which is less than nitrogen, which is less than oxygen, which is less than hydrogen. Typically, you will not see me give hydrogen in electronegativity problem, simply because I don't know of many hydrogens that can accept electrons. But since I have chosen it, I have used it. It's nothing wrong. We didn't violate any rule. But typically, you will not see me give hydrogen in an electronegativity problem. It will probably be just these guys. Okay, it makes just sense with just these is enough. But in this particular example, since I have hydrogen, that is the correct order. So this right here, folks, is the correct electronegativity sequence. Okay. I don't think I want to dwell any more than that. The rule is the same, so if you apply the rule every single time, more likely you're going to get it right every single time. But I highly recommend you follow this procedure here. This way you never get it wrong. This is something I have started doing in the last 3-4 years instead of going directly to this. I recommend students follow this pattern first, understand where everybody else is on the list, make a rough sketch of it, and then transform it into a full-blown correct sequence picture, and you would never have any problems. Alright, so I'm going to stop this video here, and when I come back for one last time on week 2, I think I've said penultimate twice now, so I promise this will be the last time you will probably see week 2 material. So I'm going to stop here, and when I come back, I'm going to walk you through the orbital and electron configuration in a box form. Alright, I'll be back.